They're saying if you're electrically qualified, you have to have in your facility CPR and first aid training.
Yep.
They're gonna ask me that when I get back.
You will get CPR trained when you get back. You already know that.
Yeah, but they were
Yeah.
still debating, I don't know if it was just, it might even be everybody complaining, I just sat and
The OSHA requirement also states that, and we can dig into that real deep if you want, there's some requirements under 1910.269 that require specific, they have specific requirements for CPR and first aid training. And the bottom line, what it boils down to is if there's a greater than 4-minute response time from any local responding agency, fire department, paramedics, things of that nature, that's when you have to have people on site trained. And the people who are doing the work have to be trained as well. So that's kind of where the OSHA stuff comes in, as well as the 70.
Yeah, I was concerned about the people doing the work. We have, on site, we have everything.
Right. If you do energized electrical work, you're going to have a second person there with you anyway.
Correct.
So your second person has to be CPR first aid trained. And trained in methods of release we talked about yesterday, either knowing where the power supply is or using a hook stick or whatever the facility requires. Because that's part of your requirement on site. Yes.
If you have 2 people on site and they're both trained
Mm-hmm.
and it's required to do CPR, is there a penalty for the person if they choose not to do that?
There is no legal penalty because it is, what's the term that they've got now? You tried to render assistance or you didn't, you can't be fined for not. You cannot be penalized for not rendering assistance. But you must call someone.
Okay.
You have to call someone. If 2 people are working, both of them are CPR trained, the first one goes in and the person down. The second person, what's the first step you want that second person to do?
Call for help.
Absolutely. First things first. Always call for help first. Beyond that, there is no criminal offense if you refuse to render aid.
Kind of like the Good Samaritan Act.
That's Good Samaritan law, that's right,
Okay.
that's what it was. Yeah. Okay.
Yeah, because I've been in a couple classes where people have said, yes, we're required to take this training, but I don't think I can do this.
Yeah, right. And that's something that you, as a person, you personally have to decide.
Right.
What's the worst that can happen if somebody goes down after being electrocuted? Okay, let's talk about the difference between receiving a shock and being electrocuted. Are they the same? What's the difference then?
You're shocked when you can still function. If you're electrocuted, you cannot.
Electrocuted is dead.
Right.
Yeah.
There is no coming back. Shock means you've received an electrical shock, you've received electrical current. If you have been electrocuted, you are dead. Bottom line. So even something is not going to harm that person anymore. Even chest compressions is not going to harm that person anymore. Okay. All right, anything else? No? Okay. Well, let's get started on electrical lockout tagout. We talked yesterday about your lockout tagout program. You thought was a pretty good program where you're located, right? Anybody that is exposed to any type of electrical hazard. Now what's considered an electrical hazard? We looked at the pictures yesterday where it showed normal and abnormal conditions, right? What was the difference between those 2 pictures? Normal means what?
Normal operating procedure.
Normal operating procedures.
It's enclosed.
All the covers are in place. All the screws are holding the cover in place. The minute you take those covers off, you are now in an abnormal operating condition. You have exposed energized conductors. You've got the potential for making contact with them. Okay? The minute you pull those covers off, what has to happen?
They have to put PPE on them.
Before the PPE is even put on, what do you need to keep, who do you need to keep away from there? Unqualified persons, right. You gotta make sure that your unqualified workers are there, or are kept away from there. Okay? Locks and tags. Or locks have to be tagged, tags have to be tagged, right? But how do they have to be identified? Who has to, locks have to be identified with what? Your name, who it belongs to. Some companies have a photo ID that attaches to it.
Yeah.
Some companies just have a band around it, around the base of the lock, that says this lock belongs to whoever, do not remove, and all that other stuff. Right? So the lock can only be removed by the person that attached that lock, right? Are there any scenarios where someone else can remove that lock?
If you do not work for the company anymore.
Okay, if you don't work for the company anymore,
So that you come, say like the shift today you worked,
right?
you went home, you got in a wreck and you're hospitalized. Or
You can't return to the job
right,
site.
you can't return to the job site, so the supervisor would be able to take
Right.
that off.
How would he take it off?
Normally a supervisor, we have locks, we have a set of keys for each of the guys' locks in case something happens.
Okay,
And we
we'll
would
talk
go
about that in a second as
Yeah, what
well.
I'm gonna say is we'd go through our base safety on that issue as far as removing that from
Okay.
the circumstance and get their authorization.
There's a written procedure that you follow, right?
Correct.
Okay,
Normally, on our base, if we're working an 8-hour shift, and at the end of the shift, if it's still gotta be locked out, tagged out, then I would put we would change out the individual's lock and put my supervisor lock on that, in case
Okay.
something happened. You see what I'm saying?
right.
That's a procedure.
So that's a turnover scenario.
Correct.
Where that 8-hour worker would do a turnover of that lockout process.
Correct. If it goes beyond a normal shift, then the supervisor's lock goes on.
Okay,
And that's base procedures, but if someone was injured and couldn't make it in, then you would have to go through base safety for the authorization, and they either say yay or nay or what.
Okay.
It's their decision,
that's their
and that's
decision.
that's our.
And that's the base written procedure.
Correct.
Absolutely. So what you need to do is follow your written procedures. Tim, you've got written procedures you're going to get into when you get back there through your lockout tagout program. But what it boils down to is this. The person that attached the lock is the person that removes the lock. There are various exceptions to just about every rule, but bottom line, you put it on, you take it off. All right? Who is authorized to work on circuits that are over 50 volts? One word I want to hear.
Qualified.
Qualified, exactly right. And remember that 50 volts. We talked earlier yesterday about the 50 volt limit. What level of current can cause ventricular fibrillation? What was that number yesterday? How many milliamps? 75 milliamps at 1,000 ohms, right? So the human body can have resistance as low as 1,000 ohms. And at 50 volts, how many milliamps is that? 50. Is that below the 75? So there you go. All right? Does it make sense that whoever that qualified worker is capable of working safely? You have to make sure that you're not going to have a qualified worker who does not work safely, right? You got to know what your procedures are. You have to know what those hazards are. What are some of the requirements for becoming a qualified person?
Training.
What kind of training? I know that was coming up, but what kind of training? You're absolutely right, Dale. Training in recognizing what?
Hazard.
The hazards, that's one. How to determine
The proper testing equipment.
Proper test equipment, okay?
Choosing the right PPE.
Choosing the right PPE. Mike? Determining nominal voltages, you gotta remember that. In order to know what proper test equipment you need, you have to know what the nominal voltages are that the equipment's operating on, right? Okay.
Don,
Yes?
forgive me for appearing ignorant, but I've always heard that word nominal, and I've never understood what it was, what it meant. Nominal.
Nominal,
Present?
not necessarily present, but nominal, we'll interpret that right now as normal operating voltages.
Okay.
If you've got a piece of equipment that operates at 120 volts, your voltage may read, with a digital voltmeter, it may read 122, 123, maybe 118, but the normal nominal operating voltage is going to be 120. Same thing with 480, something along those lines, okay? Nominal is going to be normal operating rating.
Thanks, sir.
Sure. Okay. What else we got? 130.6, alert. Alert, alert, alert. What does that mean? What's another word for being alert?
Being aware.
Being aware. You have to be aware of what the potential hazards are anytime you're working on equipment operating at 50 volts or more. What's the number one potential hazard that we've been talking about? The most common one. Shock hazard, right? Don't get yourself in a scenario or a situation where you can come in contact with those live parts. Make sure the covers are on. If they are not on, you have to make sure that you have all the proper protective equipment. You have to have barricades set up. We're going to talk about it in just a minute. This is a good one. When impaired, make sure that your people are not impaired when they're trying to work. And what does impaired mean? What's the first thing that comes to mind when you think someone is impaired and unable to function safely and properly? What's the first thing that comes to mind?
Leroy.
Handicap.
Handicap, meaning
Unable to perform a certain duty or task based on the limitations of.
their physical limitations. Okay, I'll buy that.
Ron Jenkins.
Could Ron drinking, consuming adult beverages? Would that be impaired? Sure. What else? That's usually the first one that comes up.
You could be on medications,
Medications.
because, there's a lot of people taking medications daily
Absolutely.
that are prescribed.
Absolutely.
Some of that can cause other effects.
Oh, you bet it can. What else?
Sickness.
Sick? You got the flu,
Come into work feeling pretty good and you start feeling lousy.
feeling kind of puny when you get to work in the morning, and then as the day wears on, it's just don't feel good. What else?
Overly tired,
Pardon?
overly tired,
Overly
fatigue.
tired. Absolutely. What if you're on a 14 or 16-hour day and you're in the middle of a process or project? You think you're going to be as sharp as you were when you first got there in the morning? Chances are you're not. So make sure that you're not impaired in any way. Be it tired, under medication, whatever the case is, make sure that you're not impaired, because that's going to cause you to get yourself in a situation where you can get yourself and somebody else hurt. Okay? Now, the safety programs that your companies or your facilities are going to have in place is going to outline a lot of different things before you begin work. The first thing you do, what did I tell you you have to do before you start any job? I said yesterday, there's something you need to do.
Assess the hazards.
Assess the hazards. Look for a way to get hurt, and then don't do it that way, right? That's also called a job briefing, or that's part of a job briefing, to do your hazard assessment. You look at the job, you write down what the task is. There's a briefing sheet that you can use. There's one in the back of the 70E as an example you can use. You can develop your own. These documents that are in annex, the annexes in the back, they are not required documents, they are examples, okay? You can draw up your own, but the main thing you want to look for is the task analysis. What are you going to do? How are you going to do it? What's going to be required? What are your safety equipment? What are the proper tools you're going to use? Things of this nature. Do your job briefing before you start. Remember that little mom and pop shop I told you I used to work for in Albuquerque called Intel? They had a little thing called a pre-task plan, which was a written form. You plan your job and then work your plan. Step by step, everything, and if conditions change, what do you need to do? Stop. Take a time out, back away before you get yourself in a situation, and then redo your plan again. Do your hazard assessment all over again. What would be the situation where conditions might change? Let's say we're all working in this area and we're installing a new lineup of switchgear up against the front wall.
Unexpected shutdown, loss of power from the plant.
Loss of power, big time. That's a big one.
Construction crew working down the block, maybe affect the power downstream. or
You're
something.
right. Somebody else doing other work, maybe not even in your location. But what if you've got welders that are working in your area? What if you've got sprinkler installers and you're installing switchgear? What's one thing that doesn't go well together? Water and electricity, right? Okay, so if the work area changes, if you get a new crew or somebody else new on the job,
You could be following your design as the installation and it not match what's there.
Uh-huh.
It's a complete stop in.
absolutely. Do your design plans always match your as-bills? No. Why not? Because you may have a half an inch, not enough room to put that lineup of switchgear in. Is it going to fit now? What can you do to make it fit?
Where you back up and discuss it.
Okay, let's take a time out and figure this out. Let's call the designer in and say, look, your measurements were off by a half inch or whatever. Your situation has changed. You stop and make that assessment. Other work in the area, work on the same circuit, emergency response communications, any of these things change in your job briefing, you need to stop. Okay? If it's the same task over and over and over again during the same day, do you have to stop before each task and redo your task plan again all over? No. If it's a repetitive and it's the same exact task, if there's something different about it, you need to reassess, all right? All right, Ron, you guys have overhead power lines, don't you?
Yes,
You were telling me all about that yesterday with your workers around there and people in the yard, you know, picking mangoes out of trees with aluminum poles and stuff, right?
it's Leroy.
Oh, he was doing it? Okay. Unqualified persons with overhead power lines. Are those mango pickers qualified electrical workers?
No, they're not.
Then why do they continue to get electrocuted or shocked?
Ignorance of our, I won't say ignorance, but I'll say unfamiliar with what's around them, surroundings.
There you go. Their surroundings.
Right.
They're not familiar with their surroundings, and people tend to focus on one thing that they're doing, so they do it right. They don't have the peripheral vision or the knowledge to look around. Okay? So that's where people can get in trouble. Your overhead power line's minimum clear distance for unqualified persons at 50,000 volts is 10 feet. Minimum clear distance, 10 feet. For every 10,000 volts over 50, you increase that by 4 inches. So if I got 70,000 volt overhead power lines, what's my minimum clear distance? 10 feet, 8 inches, there you go. Got it? 80,000 feet, 80,000 volts would be 11 feet. Okay? Just keep adding 4 inches for every 10 kV above 50. Now, that's for unqualified persons. Qualified workers have different requirements. They can get a lot closer than that, can't they?
Yes.
Why would they be able to get closer?
They're qualified, they're familiar surroundings and the hazards that are there. They're trained.
There you go. They've had the training, they know the surroundings, they know the hazards. Supposedly, they know what they're doing, right? Okay. If you are moving a truck, a crane, a dump truck, near overhead power lines, like we talked yesterday, dump truck goes up like this and pulls forward, takes out power lines. Crane making a swing around an area. Minimum 10 feet. Okay? Now what does this mean? It says may come within 4 feet if it's in transit.
In transit, meaning that the boom and everything's not operating, that it's,
Down and in the cradle,
and in transit moving.
you're driving it.
Correct. You're not it's not operating for work, it's you're driving it from point A to point B.
The minute you stop that vehicle, what's your minimum distance? 10 feet, because it's no longer in transit. Okay? And again, that's at that 50,000 volts.